Hello children, yesterday we have started with a new chapter, number system. Today we are going to continue the same. Okay? So, in the last video we have seen about natural numbers. Natural numbers, it was denoted by capital N, and it is an infinite set with 1 as a least number, and it consists of the numbers 1, 2, 3, 4 and so on. So which is the least natural number? It is 1. Also we have seen it was also called as counting numbers. So natural numbers are also called as counting numbers. Next, it is whole number set. It was denoted by capital W. So how whole number set and natural number set differ? When we add 0 to a natural number set, it becomes a whole number set. Okay? So whole number set is an infinite set which consists of the numbers 0, 1, 2 and so on. Okay? So I can say that every natural number is whole number, but every whole number is not natural number, since 0 is a whole number but 0 is not a natural number. Okay? Next, we have seen for integers. Integers, it was denoted by the letter Z, and it is the collection of what it was, natural numbers, negative natural numbers along with 0. Okay? So I'll be having here 1, 2, 3, this side it is -1, -2 and so on along with 0. It consists of your integer set. Okay, so every whole number is an integer. Yes, because 0 is included in integer set, but every integer is neither a natural number nor a whole number. You can give an example. -2 is an integer, but it is not whole number or it is not a natural number. Next, it was a rational number. Rational number, it is denoted by Q. You remember what was that Q? It was nothing but quotient. Okay, so Q is a rational number set. Now, what was a rational number? It can be written as P by Q, where P and Q are integers and Q is not equal to 0. Also, we came across they are co-prime. Co-prime means there is no common factor other than 1. Okay, so only 1 is the common factor. This is what till yesterday we had seen. Now, there are some numbers which will not come in this form. Okay, and such numbers, they are called as irrational numbers. They are the irrational numbers. For example, if I write this numbers √2, √3, √4, √4 it won't be there because √4 is what? 2. Okay, so that won't be. So it is, I can say that √2, √3, then √5 and so on. Okay, so these are all irrational numbers. Now you may think that your irrational numbers, what will be the actual definition? We can say that irrational numbers are the numbers which are not rational. So how we can write the definition for irrational numbers? It is the numbers which cannot be written in the form P by Q are called irrational numbers. Now you may think that √2 is an irrational, I have said, but I can write √2 as √2 by 1. Yes, P by Q form. Then why it is not irrational? Then why it is not rational? Yes, but the condition was P and Q should be integers. 1 is an integer, but root 2 is not an integer. Okay, so I cannot say that root 2 is an rational number. I cannot say. So it should be what? Irrational number. Hope that is clear. Okay. So the examples root 2, root 3, root 5, root 7, root 11 and so on. You have again infinite collection of irrational numbers. It is not a finite collection, it is again an infinite collection. So this is what your real number set. It is a collection of rational numbers and irrational numbers. Okay, that rational and irrational are separated set, two distinct set. Okay, so combination of or collection of these two sets, it forms a real number set. It is denoted by capital R. Real numbers, capital R. Okay, so it is denoted by R. Every real numbers are the collection of rational numbers and irrational numbers. Then rational numbers and irrational numbers are distinct collection of numbers. Distinct in the sense there is no common between them. See, from here in the figure itself we can see there is no common between these two. I have a space between them. So they are distinct. They are separated collections. Okay, then no rational number is an irrational number. That means I can say 2 is rational, but 2 is not an irrational number. Similarly, no irrational number is a rational number. Root 3 is irrational, but root 3 is not rational. Clear? Next, every real number is represented by a unique point on a number line. Unique point, that means, suppose if I draw here a number line, I am writing here 0. This is 1. This is 2. This side is -1. So whether 0 is a real number? Yes. Every real number has a specific position on the number line. Okay, if I'm saying 0, 1, if I want to plot 1.5, 1.5 I will plot in between 1 and 2. Yes, it will be between these two. Clear? So it has a specific position. Unique in the sense, suppose if I take the hand impressions or the thumb impressions, we all know that thumb impressions of every person are different, even though if two are twins. Okay, or then also if we take the thumb impression, they are different, so they have a specific. Okay, so each and every one, it has something specific quality. Okay, so here in the sense we have unique point, so every number can be represented at a unique point on number line. Hope the concept of unique is clear. Okay, then every point on the number line represents a unique real number. The same thing, this is 0, that means this point 0, it represents a unique real number, a specific real number it represents. Okay, it will not represent any other real number, but it will be 0 itself. Then we'll see some questions. First is, every irrational number is a real number. You have to tell whether it is true or false and you have to justify the answer. So question is, every irrational number is a real number. Yes, from this figure what can you say? Whether this set, irrational number set, is contained in the bigger set of real numbers? Yes. And hence what can I say? It is true. Since real numbers, it is a collection of rationals and irrational. Okay? Justification, is it clear? Next is, every real number is an irrational number. What can you say for this? Every real number is an irrational number. Now, this is my real numbers. Can I say that every real number is a rational number? No. Why? Because I have 2. Whether 2 is a real number? Yes. But whether 2 is irrational? It is not. Is that clear? Every irrational is real, but every real number is not irrational. You can give any example from this set. Okay? I have -1 is a real number, but -1 is not an irrational. Okay, so the answer is false, since 2 is not irrational number. Okay, next question. Every point on the number line is of the form root m, where m is a natural number. See what it is? Every point on the number line is of the form root m, where m is natural number. Now, on the number line, do we have only natural numbers? No, we have negative numbers as well. Suppose this is 0, left hand side, here it is -1, -2. Okay, so can I have, if I take square root of this, yes, whether that -1 will be a natural number? No. So that is not true. Okay, so what we can say? False, since no negative number can be square root of natural numbers. Okay, hope this is clear. Next question. Are the square roots of all positive integers irrational? If not, give an example of square root of a number that is rational number. Question is, square root of all positive integers, are they always irrational numbers? Now, if I write it as square root of 4, what is square root of 4? I am taking only positive square root. Okay, you may say it is 2 and -2, but till now, till your 10th standard, till this 9th standard, will be considering only positive square roots. So square root of 4, it is equal to 2. Okay, so I have written what? Square root of all positive integers. Whether is it irrational? I am getting answer is 2, but whether 2 is irrational? No. So this is false. Okay, so what it is? No, since root of 4 is 2. You can give any other example. I am writing root of 81. Root of 81 is what? 9. But 9 is not an irrational number. Clear? Next. Here we consider only positive square roots of the number. That is what I have said. We are considering only the positive square roots. Okay, we are not taking the negative. So hope in this video, whatever the concept of irrational numbers is clear in your mind. Thank you.